Okay. So I was wondering if it's okay, I'll be a bit informal, but also I like to take notes and Google things, and I really actually have a very hard time with Dutch names. But I was just trying to, when you introduce yourself, maybe I'll just Google you so I at least can see how you spell your name, and I can look up what you do later.
I was making an email with the names.
Oh, perfect. Okay, great. Okay, so it's okay.
Yeah,
Great.
sure.
Okay, cool.
Yeah.
Because yeah, it's very hard for me to spell and remember them. Yeah.
I'll need a note, although I know exactly what Joseph is doing. So I'm very pleased to welcome Joseph Williams here, all the way from the States. I think he's one of the key catalysts of improving online learning through experiments, which is a great thing. He's a research fellow at Harvard X, which is the online education component of Harvard University. He's also a member of the Intelligent Interactive Systems group of Harvard, and he's currently leading the advisory board for a large fund that is on enabling randomized controlled trials for within actually every large-scale online learning environment. And he does that using assessments, which is like intelligent tutoring software. And Emily and I are trying to use it within Coursera at the moment. And Joseph has also worked, for instance, with edX, with Khan Academy.
Mm-hmm.
So he knows his way around all these large-scale educational environments, for sure.
Okay, cool. And I wondered, could we just maybe get quick introductions?
Sure.
If you don't mind seeing your name and what you're working on, I'd be curious to hear. So I guess I know Alexander. I can do it, Alexander Savvy, and you're working on you said putting A/B experimentation into Math Garden.
Yeah.
And you
together with me.
Ah, okay. Okay.
Sam Scholten. I guess that translates. Well, no, it doesn't.
Okay.
I guess that's the way you would pronounce it. I work at child development and education,
Okay.
and social sciences, and faculty of behavioral and social science. I do like 3 different jobs.
Uh-huh.
Very busy. And I created my own MOOC.
Okay.
I'm working on specialization of 5 MOOCs on methods and statistics.
Okay.
We just started test takes for the second 2.
Round. Okay.
The first one's done, second one's done. No, the third and the fourth. We're starting on now, and we want to use that opportunity to do some A/B testing.
Okay.
Yeah, that's
Okay.
basically it.
Great.
Yeah, I'm Frederik Bormans.
Okay.
Well, as I told you, I work on the scoring rule part of the Math Garden framework. That's one part of of what I'm doing, but I'm also well, my work is more related to misfit in the whole framework. Children that do not really fall into the descriptions of the psychometric model that analyze Math Garden. So not responding in accordance with the scoring rules. One that type of misfit, misbehavior. Another type is another type of misfit can be related to people that really do not respond to the model that underlies Math Garden. But this is more related to children that respond according children that do not respond according to the psychometric model underlying Math Garden.
Okay.
In any case, well,
That's okay.
So yeah, we already spoke. I'm Maarten Marsman. I used to work at CITO. It's the largest, or almost the only Dutch testing company. So it is in America, but much smaller. And yeah, I used to work in psychometrics. I'm still doing some psychometrics, and mostly in the Bayesian part, where I work with Erik Wageman, so statistical program Jazz, and after the rest I do all in all. On and off things in education statistics.
Okay. Cool.
And so we also just met. My name is Nicola Ruijs. I'm from the education department before I was in the econ department. I'm usually working on evaluating policy interventions for education mainly, and what's relevant for her, so I'm also working on maybe related to that.
Okay, great. I'm sorry, I feel very dumb, but whenever you say your names, like I have such a hard time visualizing, but I think if I heard them 10 times and you send the email, I can then remember.
Well, the next difficult name. My name is Ilya Cornelis.
Okay.
I'm an education economist based around the corner in the econ department.
Okay.
And I'm currently involved in the impact evaluation of a computerized adaptive practicing algorithm, in which we compare the results from an adaptive algorithm to a more static algorithm.
Okay.
And actually we presented that 2 weeks ago, I think, and from 2 weeks ago, almost now we're part of the team.
Oh, nice.
to visit these sessions. We learn a lot from it.
Great. Yeah, and when we share, if you don't mind sharing some slides or something on that, I'd be interested in hearing.
Yeah.
Okay, Sharon Klinkenberg. I built the first version of the Math Garden.
Oh, okay.
Implemented a computer adaptive algorithm. Did research on the effectivity of the algorithm, how valid is it. Still interested now in the discrimination parameters of the model for the items. I'm also heavily involved with implementing an assessment system for the UVA and the HVA. To implement one big assessment tool for the whole university.
Okay, great. Okay, all right, thanks a lot. Yeah, it was great to hear what everyone's doing. And Alexander already introduced me, but one thing I'll add is I'm originally from Trinidad. So Trinidad and Tobago in the Caribbean, so that's why my accent is strange and hard to follow. So don't hesitate to interrupt me or ask me to move slower. It's also actually hard because Dutch people can speak English very well, so I start to assume they're like American. I can speak very quickly, but then nothing makes any sense. So I'll do that again. Oh, I hope this is me trying to keep track of my time, but it keeps popping up asking me what I'm doing. I hope it doesn't pop up 20 more times. And so so I'm excited to be here and talk to everyone because the kind of work I'm doing, I think, would be relevant to get your thoughts on. And in general, I try to collect a lot of resources and kind of know who knows about economics and who knows about statistics, who's offering MOOCs. So it'd be great to sort of see how these ideas might connect. In general, I'm always open to collaborating on any of these issues or seeing how we can share knowledge. So there's some more information on my website about the kinds of things I'll talk to, this kind of MOOClet framework. But in general, I just put a lot of things on my website about technology. So if you have any resources, feel free to send me. I can always add them. I just try and keep like a list of technology, a list of relevant education literature, economics. I don't have any of yet. And I just will put these slides in this link. It's like instead of a QR code, it's a psychological QR code. So tiny.cc Williams talk, you got to put these slides up. And you can always add notes or feedback there as well. Cool. So I think Alexander said to aim for about 45 minutes. Is that okay? And I'll try and maybe, hopefully even if I can be faster, then we can discuss. And feel free to actually interrupt me at any point and discuss something, because I don't have to get through everything. I can skip ahead. So in terms of an outline, I think what I was thinking was, actually, would you believe actually, 1 second. Made a mistake when I loaded these slides. Okay, good, yeah. Yeah, so just provide some motivation, but I think everyone here is already on board with that. A quick tour of past work, just so you can kind of see where I'm coming from. I think I'm going to go over this very, very quickly, and then you can always ask me to return to it. And then talk about this concept of a MOOClet framework that I've developed, which is really designed to enable other researchers to research. So my PhD was in mixture of experimental psychology and applied machine learning and artificial intelligence. But now I think my research is mostly in human-computer interaction, which, if you're like me 2 years ago, I had no idea what this was. But it's about designing technology for users to help. It's really about the design of technology to help people. But for me, the users aren't just students. The users are actually researchers and instructors and engineers. So actually, the MOOClet framework is a technology workflows around how to use technology that are meant to actually help make it easy for researchers to run experiments, and instructors to feel comfortable with experiments, and engineers to actually implement the infrastructure. So framework, the point of framework is actually to enable research. So it won't be necessarily as obvious like it's a specific empirical result, but it's more, are these concepts useful to you? Like, can you see a way that you might use this, or that you want to find out more and see if it can be helpful? Then I'll just talk about how this framework, one thing it's doing is allowing us to use experiments to discover personalized instructional principles. So how can we actually use experiments to test options and discover which lessons are working for which subset of users? And I'll give one example with an email study that I think is not educationally very interesting, but it illustrates the full concept. Another thing I think the MOOClet framework does is enable collaboration between instructors and researchers. So I'll talk a little bit about that. And also actually how we can actually enable collaboration among many different researchers. And the kind of key idea behind that is that if you designate components of a course, like lessons or exercises or even emails, as mini labs where we can run experiments, well, then different researchers can then contribute different experimental conditions. So you can imagine our disagreements, we can try and express them in terms of different conditions that we think are most likely to help. And then when the experiments run, it runs all of these together. And some potential online context paradigms I'm working in if people are interested. And what are things for collaboration? So things that I'm interested in working on, I'm always happy to have people involved in, and maybe if there are things that other people are interested in as well. So in terms of thinking about experiments, I think everyone here is pretty much on board with this. But to me, the biggest thing about technology is not necessarily big data or even scale that can give people many resources, although those are great. To me, it's actually the fact that the simple step of taking a student from doing their homework in pen and paper to now doing it online on a computer, if we design the technology right, and that's a big if, then basically it's combining two contexts that are normally very far apart. The lab, where we can do random assignments to different lessons or exercises, where we can control how things are delivered pretty systematically, and we can collect data. And that's being merged now with the student's classroom, where actually it's really hard to run an assignment of different versions of a teacher, where how something is delivered instructionally can vary a lot, and where data collection on pen and paper can be quite slow and limited, but also it's not normally the scale we need to do experiments. And so my hope is that basically we can find the intersection of research problems that we're interested in and practical problems we want to improve by looking at technology. So in terms of quick tour of past work, and I'm really going to jump over this, so a lot of these slides, you may not even need to look at them, or they definitely won't all make sense, but I can come back to it. So one thing I worked on a lot of my PhD was, why is it that when we ask someone why, even if I ask myself, well, why is that teacher saying this? Or someone asked me, can you explain to me why this is the right answer to a problem? We actually learn from that process. And so it's a big literature in psychology and education that asking why has a pretty powerful effect on cognition. And it's a bit strange because normally you learn because someone explains to us. So why is it that asking why can actually help you learn? And so one thing I tested in my dissertation was, is it that asking why makes people more motivated or pay more attention? So that's a general kind of account of engagement. Or does asking why have a selective effect? And the account we tested, the subsumptive constraints account, was motivated by philosophy of science, where they've actually characterized theories of explanation, said that what makes a good why explanation is it shows you how what you're explaining is an instance of a pattern. So our hypothesis that we found evidence for was that when you ask why, it forces you, like, why is that person angry today, or why is this problem correct? It forces you to interpret it in terms of an instance of a pattern. And so in fact, asking why we found drove people to search for underlying generalizations. And so this is actually helpful much of the time, but actually sometimes it can hurt. If you ask a student to explain why, and they don't have enough knowledge, they might actually find the wrong pattern. So just to show you, one example of an experiment we did with this was basically students were trying to learn to rank using z-scores. So the basic task was, if I tell you that Sarah got 85% in sociology, the average score was 79, average deviation was 8%, basically standard deviation, and the math score was 90. But then in a separate class in art history, Tom got 69, average score was 65, and so on. Well, how do you figure out who was ranked higher? Because they come from different classes. Can we really compare them? And so this is basically a task. We would give participants these scenarios and ask them to basically observe a pair. They'd be told, okay, in this case, Tom was ranked higher. And then we'd ask them to either explain, well, why was Tom ranked higher? Or we'd ask them to write their thoughts. And so that's the basic paradigm we used. And so the kind of nice thing about this setting is it's a bit ecologically valid. Not as ecologically valid as Anne-Marie's course, but it's getting there. And we actually varied whether people got observations that were consistent with their beliefs or against them. So here, at least, putting the information there for you, at least 3 ways you could try and make this decision of how to rank people from different classes. But one thing you could say is, so you find that Tom's ranked higher. Now, why is that? So one thing you could say is, well, it's whoever has the highest score. We don't care about the classes. And so if you actually use that rule, you would predict Sarah. So this observation is actually an anomaly. It goes against your prior beliefs. You could also say, well, maybe it's whoever's more above the average. But actually, in fact, Sarah's more above the average than Tom. So again, you think Sarah. So this observation is also anomalous with respect to that rule. And there is another rule like whoever's closer to the math score. The thing is that these are what people normally believe, but actually the correct, statistically more correct thing to do here is to say, well, it's actually whoever's more deviations above the average. The idea here is that, Sarah is 6 points above the average, but the standard deviation in class is 8. That's huge. So she's already only above maybe 60%, 70%. Whereas Tom now, he's only 4 points above the average, but this standard deviation is so close. So Tom's actually quite good. He's well above everyone else. And so in this kind of setting now, we can ask, well, people are given observations that are anomalous with respect to their beliefs or consistent. So I made this one specially to go against everyone's false beliefs, but most observations where deviations, more deviations above the average, you probably just have a higher score. So the question we had here was, how is asking why or explaining why someone is ranked higher versus the control condition of writing your thoughts? How does that actually drive learning? And so what we actually found was that explaining did help learning, but actually only under particular conditions. So what we also manipulated independently was whether there were few anomalies, like in every 6 pairs of those observations you saw, there were just 1 or 2 anomalies. So that meant that 4 or 5 of them would be consistent with the deviation rule, but they'd also be consistent with those wrong rules, like higher. And what we actually found is that explaining actually didn't have any benefit if there were just a few anomalies. But it did when there were many. So the effect of explanation is not always to boost it. It's very selective. If you have observations that it drives you to the right pattern, then it actually helps learning. But in fact, this is not a reliable effect, but other studies we've done suggest that explaining could actually hurt learning if it drove you to the wrong pattern. Another thing we looked at was basically how these might be distributed. And I won't get into that. But again, we kind of found that explaining, again, doesn't, even if you have a bunch of anomalies, it only helps under the right conditions where, for example, you have one observation like the one I showed before that rules out all of the other rules. So that's the overlapping condition where a single observation will not just point you to the right rule, it'll make you think that all the wrong rules are incorrect. Because in a distributed condition, you actually would have one observation that would rule out the higher ranked rule, but it wouldn't rule out that you're more points above the average. Then you have a different observation that will rule out more points above the average, but it won't rule out the higher ranked. So again, this is just established conditions where explaining will help you revise your beliefs, but actually it's giving us some boundary conditions on exactly when. So I just meant to give you a general sense or flavor of that word. One thing that's a bit more relevant to online environments, and maybe as you look at these, you might be thinking, well, how could you incorporate these into kinds of studies that people are working on here? Because that's something I'd love to talk about. But the idea here was, how do we actually now take explanation into a real-world context? So it's an experiment on Khan Academy, where basically you've got a math, so you've got a math problem. Grades on geometry midterm are normally distributed with mean and standard deviation. Stephanie got a 60. But what's the easiest score for Stephanie's exam grade? So people are solving these kind of problems, and this kind of, it looks natural when you see it here, but actually it took us, I would say, even 10 months to figure out, well, this is the experiment paradigm we want to use. Because we look at Khan Academy's math website, should we change videos? Should we send emails? Should we add other parts to it? Well, what I hit on is this is a nice experimental paradigm because it very much matches what we use in psychology in something like learning categories. Give someone an example of a problem, they solve it, they get feedback. And they do this over and over again. So we have rich dependent measures on every step, but we can actually now manipulate features of this. So to kind of map this to the kind of research I'd done before, what I did was add this simple little box above. There was just a clickable link. So click here to learn about the what, why, how strategy. And this required a lot more work than what I'd done to basically take results I had from my research, but also combine it with other people who've worked on this literature of asking why and asking how and what. And what we did was, when they clicked on this, it actually popped down and tell them, well, here's a strategy of asking yourself questions. Whenever you see a hint on a problem or look at a step of what you're working on, ask yourself, well, what does it mean to you? Or why is it helpful to take a step? How do you know it's right? And so all we actually did in this experiment was manipulate whether they got nothing at all. So that was just a practice usual condition, or whether they got this link, and when they clicked on it, it popped down. And we actually had about a 3x4x5 design here, but I'm just showing you one example. What we found, at least in the first round of studies, is that if we look at accuracy, so after we administered this on about 5 to 10 problems, we then looked at accuracy on subsequent problems. So the number of problems subsequently that they were correct, or the total number attempted, we actually did see an increase of about 0.8%. So simply adding this got people more in the habit, we hypothesized, of asking these questions and then improved learning. Of course, in this kind of study, we can't really tell exactly why it's helping. So that's where we actually now need to push back to a lab study. That's one example of one way we can map that into an online environment. And so in general, a lot of the work I've done has been on asking questions, explaining how to discover patterns, showing when explaining why it could actually be bad for learning, how asking why can actually make you use knowledge, where your prior knowledge wouldn't be used unless you ask why. It actually helps with children as young as 5. And the work I presented most recently was actually this, where how explaining makes you revise your beliefs when you see contradictions. Another thing we've looked at is how explanation relates to comparison. So instead of just explaining examples, what if we asked you to compare an example of a right answer and a wrong answer, or 2 ways to solve a problem? And one thing I've tried to do is, again, push from artificial category learning, which are more psychology kind of lab experiments, to things like explaining people's behavior to math problems and now online. So pushing towards the real world context. So any questions about that general line of work? So one other thing I've looked at is, well, how do we increase engagement? So not just focusing on the cognitive end, but how do we actually motivate people? Well, still taking a bit of a cognitive approach to it, how do we change people's beliefs so that it motivates them? And this wasn't something I did my dissertation. This was basically based on reviewing a lot of experimental social cognitive psychology and seeing, well, what actually just empirically has been shown to have a big effect that I would be optimistic about. And that basically led me to a lot of work by Carol Dweck. And she and several other social psychologists like Jeff Cohen and Greg Walton and Angela Duckworth and David Yeager, they've had these very, very impressive findings where they make pretty small changes, like teaching someone the intelligence is malleable, or teaching them to reinterpret feedback, and they get science papers out of it because an hour or 2 of training can actually have an effect a week later or even longer. So basically, the idea here is that if you think that intelligence is malleable, and we have an instrument that measures this, you're more likely to do well over time. Even if you and someone else have the same IQ or some other measure, if you think intelligence is malleable and someone else thinks it's fixed, you tend to diverge, where you keep getting better, and they either stay the same or even go a bit down. And so now with Josh Solvik, who's at Khan Academy, and a group that spun out Crowdsourcing, we tried to test this in the context of Khan Academy. And so just to give you a bit more about the dynamics of what this looks like, you got a problem and you answer it, and you can get it correct or not. If you want help, you can say, I need a hint, but a hint just basically shows you the solution step by step. So see the first line, explain how to solve the problem, you see the second, the third, and so on, and eventually you just get the answer. So the main dependent variables in this paradigm are, that we looked at these are how many problems people practiced and how many did they get correct. So again, I now think of this as an experimental paradigm. And I feel like almost the output of all that research I did, the experimental findings are nice, they're reasonable, but they're kind of weak, and we're not exactly sure on what conditions they're going to replicate. For me, at least, I'm really happy that actually I figured out this is a nice experimental paradigm. Maybe it's obvious once you see it, but we tried a lot of other things. And in a way, I can now think, well, exercises aren't just on Khan Academy. There's pretty much, they're in MOOCs. Even if everything in the world changed in 20 years, I feel like we're still going to have exercises as a sort of core component. And it's nice that they map to a sort of experimental paradigm that we can look at many different issues in. So we basically think, again, how do we randomize text above these? So we embed these motivational messages. Practice usual condition gets nothing. That's just what's there already. And now here's a growth mindset message. So it says, remember, the more you practice, the smarter you become. So that is teaching people that intelligence can change over time. So let's compare the practice usual against these growth mindset messages. So did this actually have an effect? It's just one message. I would bet that 70% of people don't even look at that message. Even if they read it, does it actually have an effect on what they do? Well, what we find there is actually an effect. If you compare the practice usual to the growth mindset in terms of how many problems people attempt, well, it's pretty small effect, but it's reliable. 35.9 to 36.2. So that's actually 0.3 problems more, which actually is about 1% increase from a pretty tiny manipulation. Now, it could be that it makes them attempt more problems, but they're just wasting their time. Maybe it's just making them think they can do well and then they don't. And actually, it's kind of discouraging. Does it actually help their learning? So we look at how many problems they get correct on their first attempt. So the idea is that if you just try a problem and you have no help, do you get it correct? Well, actually, we see the same kind of effect. Again, very tiny effect. 0.2 problems more on average, right? But still about a 1% increase in what you're getting correct, not just what you're attempting. So you're making progress. And what's interesting is it's, again, a tiny effect, but most big effects we already know about. It's these kind of tiny effects, I think, that online environments let us discover. And then this actually is pretty sizable because if, for example, these experiments were done with about 50,000 people, a 1% increase in how many problems you get correct means that about 300 students, I think, learned a skill that they wouldn't have learned otherwise. It sort of pushes them forward in their curriculum. Now, one thing I'll say is that, again, I think that we can do a lot better in this, especially in many different settings, by sort of bringing in other researchers. And I would actually love to see what people think. What's a better message we can put in? Or is there a way you can have something that's more lasting? So in looking at that, you might think, well, one is that's obvious. Why did you run this experiment? Wasn't it obvious in the research you should just have done this right away? Would we even just be unfair to all those students in control condition? Another thing is you might be skeptical, well, with that large of an end, isn't everything statistically significant once you've got 50,000 people? I don't know if there's an expression in Dutch of shooting fish in a barrel. Okay, yeah. Well, here's a second comparison we ran simultaneously. We had different motivational messages. So there's a growth mindset, but we also had these encouraging messages. So for example, would be some of these prompts are hard, so do your best. So these kind of messages that they're very subtle. They encourage people, but they don't specifically say that you get smarter through effort. So does any encouraging message at all work? So here's actually just a brief look at the kind of messages. All the growth mindset message are things like, your brain gets better the more you use it, making mistakes, opportunity to get smarter, whereas this could be things like, it's a tough problem, you can do it. Always do your best and get something out of it. And then some more things like study tips, concentrate and you'll succeed. So if we compare these now, what we actually find is the growth mindset message is actually still better than these encouraging. In fact, the encouraging messages aren't any better than no message at all. So even though looked almost like we might have been unethical to not give people these growth mindset messages. I actually wonder if it would have been unethical not to run the experiment. Because if we hadn't run the experiment, we'd have put these messages out there and it wouldn't have been helping anyone at all. Maybe we're wasting their time, or maybe we're making them start to disregard advice. So it doesn't affect either in how many they attempt or even in how many they get correct. But the growth mindset messages are better than either nothing or those encouraging messages. What's interesting is people believe these messages are equally effective. So I got a random sample of about 80 adults online. And what I did is I showed them both groups of messages, so they had time to read through. And I said, well, look at these batch of messages, messages A and messages B. Do you think they're equally effective? 52% said yes, these are equally effective. 18% thought the mindset are better than the encouraging. 15% thought the encouraging were better than the mindset. And I think this is probably just noise. You can always double the sample. And 8% thought neither were effective. So people's beliefs about the messages don't mirror the empirical data. It might be nice to just kind of study with teachers, or even anytime we're running an experiment, maybe we can kind of think of this as additional measures, get people's sort of priors about how likely something is to work. So the idea, I think you're all pretty on board with what the kind of implications might be. Even if they're intuitively classified, seem to have very different effects, and maybe we can get large scale benefits through pretty subtle changes. One thing that was interesting is the impact of these kind of experiments, what they're done in a real world platform, can actually be a lot bigger than I would have anticipated at all. Khan Academy actually launched a campaign that was called the You Can Learn Anything campaign. So they actually went and got Carol Dweck to record a short video and an interview with Salman Khan. They started sending messages out to people. They didn't randomize it, but there's only so much we can hope for. But the idea is that just because we do these experiments in a real world context, the people who use our platform then start thinking about it, they see the data, and then they learn a bit more about the literature. So actually we can have a much bigger effect in terms of people adopting this more broadly. One thing also is in terms of on research now, Khan Academy then had a competition where they would say to researchers, well, why don't you submit some experiments? And they sort of said, well, you can add some short resources to our website. We'd send people a link and they look at it. And about 40 researchers submitted proposals. In the end, though, they actually tried to work with it, but then they went back to the same experimental paradigm I showed here. Because it turned out that when it actually just seemed to have the best alignment between something practical and something of interest to researchers. So I think almost part of it is like just discovering these experimental paradigms and then publicize them can actually enable future people to research. And that's kind of what drove me a bit more towards this kind of MOOClet framework, is how can I actually enable other psychologists and education people to do research on experiments. And this competition idea I think is actually quite powerful. The platform that Alexander mentioned briefly, it's called www.assistmonths.org. So it's like assessments but with assist. That's actually a platform now that I collaborate a lot with Neil Heffernan, who runs it. And he got a grant that actually says he's trying to change his infrastructure so that external researchers can log on, see these math exercises, and then just duplicate them and propose an experiment, which he could then run in real classrooms. Or you can use it like an authoring tool, like Alexander and we have been thinking, well, should we use this to run experiments in another setting? I think this competition idea is a very nice one we can think about. And it also connects to human interaction issues about crowdsourcing. You hear a lot about crowdsourcing, but now we're kind of thinking about, can we have some systematic, almost algorithms for putting options out and recruiting ideas from researchers and comparing them? Okay, so as a quick tour past work, although actually not too quick, sorry. So in terms of thinking, how can we scale and generalize this kind of work? This is what the MOOClet framework, I think, sort of touches on, or what is at least aimed for. Oops. Oh gosh, okay. While I reboot my PowerPoint, anyone have any questions or ideas? Oh no, I'm just rebooting PowerPoint because it crashed. So if you have any questions, now is a good time for them.
Yeah, to elaborate on the 50,000K end size.
Yes.
That's an issue. It's actually going to be significant. We're going to have some effect sizes, but we can't differentiate that from null hypothesis. Where do we go with this?
Well, I mean, maybe you have ideas too, but I think it's worth doing these experiments anyway, because I actually find that things are significantly less often than you might think. I think it's just the strongest argument for having multiple control conditions. You know, like testing 3 things at once and then seeing if there's an effect. And if there is, then incorporating a new version that tests something to see if it can be even better, or testing it later, you know, a month or 2. But actually, at least I found a lot of things you'd think would be significant actually aren't. One thing that happens sometimes actually is because the population is so heterogeneous, like those 50,000 people are participants. Some of them are just you clicking on the site. Some of them are students in classrooms. Some of them are older people trying to relearn. Some of them are teachers. So being able to segment them would be really helpful, you know, for knowing, even if you get an average causal effect, what's the causal effect between groups, you know.
I'm also wondering how heavily was the manipulation used over time? Is it one set of questions? Is it over an entire course?
So in Khan Academy, it's pretty unstructured. So there's not really a clear idea of a course. They're more like trajectories. Those math exercises for the growth mindset were 10 different fractions exercises, like adding and dividing, and it's used over a period of 3 months. What we found actually is that the effects definitely declined over time. So what I showed you was a very conservative on average. The effects were strong in the beginning and weaker at the end. Okay. In terms of MOOClets, so here are maybe some examples of things that could be MOOClets. So different messages, the messages you show above a math exercise, the links that you put and what strategies they suggest to people. In a way, actually, it's kind of like this idea, well, that portion of a web page or from that could be a MOOClet, and what that means is that it's a modular piece of a MOOC, or actually even an on-campus technology. It's not like a mini course. It's more like a piece of a technology that you can then think about making different versions of and experimenting with them and then trying to personalize them. An email, actually, you could also think of one. So the idea is that really, I'm thinking this is a framework where we're basically defining what piece of technology can we make different versions of that the instructor is happy with and that researchers want to then test studies with. So the big problem I've had working with Khan Academy, with edX, with Moodle for on-campus experiments, eventually I was able to run things, but there's this kind of gigantic wall. You know, when I look at that, what parts of that can I change? Could I run an experiment in, you know? Is it this text here? Is it the exercises? Is it emails? There's a technological question of what I could actually do at all. Then there's also the question of what is the instructor willing? Also, what's the instructor excited about? Are there things where if I do a study with them, they're actually going to think I'm doing them a favor because I'm helping them test out things that they want to improve or haven't had time? So the idea behind this MOOClet framework is saying, well, let's designate pieces of these courses or pieces of our technology, emails, anything, where the person running, the practitioner like instructor and the technology people are open to there being different versions. And then these versions can be delivered based on a set of variables linked to a user. So it's user variable store and a set of if-then rules. So the idea here is that normally you have to go and do a bunch of messing around with code, but the idea is can we kind of actually designate this little MOOClet where there's going to be a little sectioned off silo that says, here are the variables of a student who lands on the page. Here's what they did before, what they said in a pre-course survey. And then here's a set of rules for delivering content. You know, if they're in condition A, then show them version 1. If they're in condition B, then show version 2. And the key idea here is that these are not necessarily modifiable by someone external to the platform, but someone external to the platform can see them and can basically send a proposal. They can say, well, here are 4 different versions of that explanation, and here's some rules for delivering it based on these variables. So that means that someone can just go and add another variable. It's like Alexander's experiment, conditions A, B, C, or D. Ninka's experiment, you know, conditions V1, V2, V3. What's also nice about this setup is it's actually not that hard to implement engineering-wise, at the beginning at least. Later on, it can be harder. Like I've had this in edX using iframes, where I just iframe in basically one of these MOOClets, and I have my own system set up. But it also allows you to do personalization at the same time. So it actually takes advantage of this fact that experimentation and personalization are really formally equivalent. They're just two sides of the same coin. When we're experimenting, we're presenting, version 1 based on a random variable, a variable set random like A, version 2 based on variables set random like B. When we're personalizing, we're delivering on a version like set based on user characteristics. So if the pretest is less than 50, show version 1. If it's greater than 50, show version 2. So that's a simple thing to state, but now we're implementing technology that enforces this equivalence. So this technology in MOOClet never does experimentation unless it could also do personalization just by changing that variable.
Where do you get the variable information from?
So that's actually, there are ways that I do it when I set it up. So for example, when I set this up, I do it by pushing information from other MOOClets. So if there was a MOOClet on this page, there might have been one on the page before that had some quiz, and so then it pushes pretest. Another place I do it from is basically the pre-course survey. But the kind of idea is that this is really a framework in the sense of it's not necessarily answering that question, but it's making it easier for you to answer that question. So it says whatever variables you can make available, stick them in one user variable store, and make it possible for them to be used conditionally.
Yeah,
but you might say
that looks to me as the simple part. The hard part is getting
The
the variables out of Khan Academy. Do they have an API where they say, well, you can get the rating of the users to use in your MOOClets?
yes, exactly. So it is definitely So then the what this would then say to Khan Academy is when you implement A/B testing, actually, I would say, if I'm being controversial, they implement A/B testing wrong. They implement A/B testing not using this design pattern. And it's because of that now that it makes it really hard to do personalization. So what I would say is when you implement A/B testing, then why don't you do it in this way? It looks dumb at first, right? Actually, let me slip ahead the slide that really, So kind of on that issue, well, here's just a bit more information about it. I do have to give instructions on how to set it up exactly. So just email me and I'll do it. I just haven't got around to it. But A/B testing is so widespread. Everyone in the world knows now A/B testing. All these software companies do it. But it's unnecessarily limited because when you implement A/B testing, you're not thinking about personalization. You're thinking about, I want to test some options. And I think that's actually a psychological barrier. On the same hand, when you do personalization, Khan Academy does personalization in a totally separate part of their website. They could have also used that to do A/B testing. So the kind of key idea is, here's one way to do A/B testing. And it's not just Khan Academy. Even at 6 months, which is great for experimentation, did it, I think, in an unnecessarily limited way. Even I, when I've run experiments 2 years ago, I think I did it wrong because I didn't allow personalization. Here's one way of doing A/B testing. When you hit the place, give one of these versions randomly. That's what edX does. That's what the systems does. And that's totally reasonable, right? Here's one slightly better way to do it. When you hit a place, that like lesson or exercise, assign people to these different versions with a certain weight or probability. That's one thing that Khan Academy kind of does, which is nice. But neither of these actually take the full step up to saying, and because it looks odd, right? When you hit a place that you want to assign variables like a lesson, exercise, and email, do this. First, with some probability, assign people to condition A, B, or C. Then, determine which one is presented by looking up the variable condition and then seeing its value and then showing a version. That's totally unnecessary for A/B testing, right? Like that's just unnecessary formalism. So you can see why people don't think of it, but actually now it has this hidden benefit. If you want to do personalization, you can do the exact same thing. Because now when you look up the if statement, all you do is swap out the variable. And you say, well, now it's going to be pretest less than 50. Well, actually, don't look at that quite yet. But now you can say, like, if pretest is less than 50, then show version 1. So I agree with you that how you make those variables available can be a bit challenging. But again, this is not meant to sort of totally solve that, but it's meant to say, well, when you set up your framework or your A/B test and personalization, this might be a good way to do it. So the idea would be, for example, pre-course survey stuff, I can just tell you in MOOCs. And in Coursera, for example, I don't know if you use their built-in pre-course survey, but if you use something else, then you could actually pipe pre-course survey stuff into here. One other approach that I do use is whenever whenever people in edX now, when people enter information, and even edX can't get it for a week, which is funny. What I do is I send information both ways now. If someone just types in, answers a question, send the information externally to this user variable store and send it to edX. And send it somewhere else if you want, just for fun. But the idea is that there are pretty easy ways to do this, at least using technology called learning technologies interoperability, where I now can iframe in Qualtrics or something else. People fill it out. I send it to the user variable store, and I also send it to edX. So that is, the data can go both ways.
LTI.
Yeah, LTI, yeah, exactly. And so that's one way we can get variables. But again, this is kind of a solution where the constraints are minimal, and that this could still benefit you even if you're just going to do it for one explanation, because maybe all you input is basically, you ask them to rate, how well do you think you understand this topic? And that's the only variable you have. And that's limited, but at least it's something. But as you add more information, it's kind of like a buffet solution. There must be a better word for it. But it's like, if you want to take one plate, that's fine. If you want to take 2, 3, 1,000, then that's great. In an ideal world, the whole course is a bunch of different MOOClets. But if it's not, that's still fine. Okay. Yeah, so this is basic. So I mean, I would actually be curious, as you look in Math Garden or other settings, because I think I'm saying one solution here, but there are going to be many other barriers that come up. So I'd be very curious to sort of hear what you're doing and how this might be relevant. And one thing I actually think is that paper that's basically on comparing platforms that did experimentation. I'd like to write a better version of it that incorporates these ideas about personalization. So I was speaking to some people at Harvard who implemented A/B testing with Canvas. But if you'd be interested in looking at Math Garden, even just interviewing you about the barriers you face and what's useful and not would actually be nice for that. One thing that I'm going to emphasize is that before I just said let's do experimentation or personalization, but actually we can now think about actually doing a combination of them, right? So let's imagine, for example, someone's pretest is less than 50. 80% of them get condition A, 10% B, 10% C. If the pretest is greater than 50, 50% A, 6% B, what this is basically doing is we're kind of now thinking of it more as a continuum. We're still personalizing because we're giving people different things based on their features, but we're not doing it in a discrete way. We're basically saying, let's use features of users to change the weights or the probability of them getting different conditions. So essentially weighting our experiment differently. And I think actually the next session I'll show this actually I think has a lot of power. It starts to make connections to think about things like Bayesian interpretation of experiments. So I'll skip over this kind of quickly. Just skip over this. So basically, here's an example of a page where I've implemented a bunch of different MOOClets, and here's like a more formal set of criteria, the if and only if statements for something to be a MOOClet and how you might set it up in your technology. Okay. One point I think I'll make kind of quickly is that the other nice thing about a MOOClet is that it ties experimentation personalization to a bunch of work in machine learning. And this is going to look more formal than necessary, but just so you know, there's a whole bunch of research on basically how do we experiment automatically and how do we trade off experimentation that's like discovering if something works with while we're discovering and putting people in conditions, we want to give them the condition that's best. It's sort of called exploration versus exploitation. The nice thing is that a MOOClet actually provides an abstraction where it's formally equivalent to a whole bunch of machine learning work. So what that means is that if you did it with A/B testing, your A/B testing was a MOOClet, then basically you could actually apply these algorithms to automatically do it. And you could actually then go and take the 50, hundreds of reinforcement learning researchers who I saw last week at a conference, and they would be overjoyed to find, well, we can actually test our algorithms in this real world setting. So basically you would get them working for you for free to help optimize what you're doing. And they would actually be happy because you're allowing them to see a real world application of their work. So basically, reinforcement learning is the idea that, well, if you've got a set of states of the world and a set of actions you can do, you take these actions and you might move from state to state. And you're trying to work for some reward, like being in some states is better than others. And basically, a MOOClet, the state space or the parts of the world you can be in are basically like user characteristics, like age and knowledge and so on. So they're kind of saying, well, if I get use of this kind, what actions do I take? The actions, and that's what's in the user variable store, the actions are the alternative versions of a MOOClet. So they're trying to think, well, which one do I give to this user? And then the reward function is basically what they're trying to optimize. And so I think this is nice because this is kind of tying things that are more usually thought of in economics, like how do we, what are utilities on helping with statistics, which is normally really focused much more on inference. And the reward function now could actually be something that's chosen by the instructor, by the researcher. You might try and choose a combination. Do you want to maximize the quiz score next week, the final exam, course satisfaction? Because in MOOCs, it's not just about learning, it's also about whether they like your course. And the policy is basically what reinforcement learning researchers would send you, is saying, well, if you're in this state, then take these actions. And these examples, the models, I'm happy to send information, but multi-armed architectural bandits, MDPs, POMDPs. Okay. So here's one way that I've used this MOOClet to support interesting kind of experimentation. So the task that someone gave me was basically saying, well, we want to increase response rate to emails. So I don't think it's particularly fascinating educationally, but I think it illustrates the key ideas. We're sending out emails and asking to give us feedback. How do you increase response rate? So they basically give me their value function. They say, Joseph, I want to optimize this. So I said, well, let's set up your email as a MOOClet. And you give me a reward function, proportion of people responding. Here's the information that I use as my sort of, this is the terminology of state space or context vector, but it's basic covariates. It was people's age group and the number of days they're active. The experiments that I could run were different versions of the email. And so basically what I did was I just, in collaboration actually with the instructor and a few other people, I made different versions of the subject line, 3 different versions, different intro messages, different way of line and response. So I had a 3x3x3 design. But I did them independently because 27 conditions, if I really cared about every condition, would reduce the power a lot. But I'm actually going to analyze these independently. There might be interactions. It'd be nice to detect them, but I'm not counting on it. Because what I'm really interested in is discovering what works at all. I want to optimize some function like learning. So what it is, I started off experimenting. So for the first 4,000 people, there was about a 33% chance of them getting subject line A, B, or C. That's totally natural. Well, you can actually think of this in some sense as a prior. We have a prior that these conditions are equally likely to work. You could also maybe think of it as incorporating some idea of utility. We think that giving each of these to people is equally good for them. Well, after I got data from people, I shouldn't have a prior anymore. I should have some kind of update. So the idea is, what I see is that 3.8% of people respond to subject line A, 1.6 to B, 2.3 to C. Maybe that varies a bit across people's ages or number of days active. But what I did then is I basically say, well, let's think about the proportion of people assigned to a condition as changing based on our priors, or well, our posteriors now, our degree of belief that it's effective, but also based on our utility, how important we want to give people what's best. So I updated these to 48%, 22%, and 30%. But where did those come from? There were a whole bunch of algorithms I could have used. I actually went for something that was very simple and interpretable, because it actually has some nice features. I basically said, well, 3.8% divided by 3.8 plus 1.6 plus 2.3. Let's present the condition in proportion to how effective it was over the other conditions. And that's where I got that 48% from. So it's basically combining like updating from prior with some evidence now what our posterior probability is. But it's also incorporating some measure of utility, because I'm kind of saying, well, the bigger that, if that was 4.5 instead of 3.8, I'd have put even more people in there. So I'm kind of, again, trading off. I want to explore and do experiments, but also I want to help people. Now, how does personalization fit into this? Well, you can then just think of actually fitting different probabilities for every level of the variable. So 18 to 22, 22 to 26 years, they get a different value. And because I've got such a simple function to update, I'm actually able to do that. So basically, after those 4,000 people, I sent this out to now another about 1,700. 590 people got the old experiment, 30% chance of condition, no weighting, no personalization. About 1,200 got weighted personalization. So that's where I actually updated those weights for every one of the experimental conditions, all 3 factors, and I had different values for all different age groups and all the different number of days active. So what we find here is that random assignment, on average, response rate is 4.5%. It went up to 7.2% of my users' weighted personalization. And so that actually is a pretty significant increase. It's not as good as if I just put everyone in the right condition. But then it's it's much better than if I just did straight out experimentation. And so this is now, I think, connecting to kind of Bayesian ideas. You can start to say, well, how do we connect together experimentation versus weight experimentation, just choosing the best condition? There are all these different kind of policies you can think about exploring. And that really comes from this idea in the MOOClet of thinking, well, we have these different versions. We can easily change portion people assigned to each of them. And we can also change the particular weightings based on user characteristics. So we're kind of smoothly moving around the space of experimenting and personalizing. Here's much more interesting education examples, and I'd love to test these out in other environments or have people interested in collaborating. Here's where we give people a worked example, more like the Khan Academy assessments kind of things. Here's a problem to solve, and they can ask for an explanation or a hint. So basically, the explanations are the MOOClets. We can either experimentally test them, or we can personalize them. What's interesting here is that we're basically, after people see explanations, we sometimes ask them, what was unclear, or what could you improve? So the thing nice now is we can add in new versions or new experimental conditions. Because the one advantage of implementing technologies in MOOClet is that even if an instructor was just in a rush, if they implement the explanations in MOOClet, the first time around, they might just give one explanation or two. But it means that at any point, either new ideas from learners or other people can then just be added in. And again, assigning 100% of people to that, it's not a big deal to say, let's put 90% of people there, 10% is new one. As we find it's working, we can slowly scale it up. So it's more a framework for saying, let's deploy technologies in a way that we can identify pieces of components, and these can be constantly improving over time with new ideas, or just with new data about what's working for who. Another one is actually, this is a study running right now, so again, it'd be very interesting. People are interested in collaborating or trying these kind of things out in the courses that you work with, like Math Garden or Coursera. But basically, the MOOClet is, we tell people, click here for a learning tip. And it's above any video, any exercise. Very much constrained by what the instructor is willing to allow. That's why it's click here for a learning tip instead of just seeing a learning tip. They'll see that about 10% of the time. But at least whenever they click there, we give them different versions. And so here it's a bit different because the same person's seeing this like over a course of 4 weeks. So every time they click, they might see different versions. But we can actually start to personalize the tips to different people. The big challenge here is, I think, going to be able to see if it's having any effect at all. For example, if they click, they might get a message. This is motivating. They might also get something like, ask yourself these questions. How am I trying to approach it? Is there anything I might be missing? So kind of combining the motivational and prompts to explain I mentioned before. We're here manipulating different messages, different prompts to explain, but also doing it so that sometimes you just get prompts and sometimes you just get messages. So we're trying to see, is there now an independent or additive benefits when we put them together? I think I mentioned this about the idea that you can make one of them, you can make as many of them as you like, but then they all add in data. And I think the kind of key idea here is we want to optimize something like student learning, but let's optimize it by breaking up the problem into these modular pieces where we optimize lessons or exercises and independently and put it all together. Okay. So I just want to close off now, but as I mentioned, it's kind of making it easy for instructors and researchers to collaborate because they can designate these kind of modular pieces. Like, is it the questions underneath the video you're willing to let someone experiment with? Is it the explanations? And the instructor can actually say in this framework, well, I would really like you to maximize grade on weekly quiz, but I'll also give you these other dependent variables. I'll also give these user characteristics, accuracy, what someone said their goal for the course was. And then the researcher now says, well, here are the versions. And the instructor, again, can quickly say, oh, yeah, this is reasonable, that's not. Whereas, at least when I've done this in the past, it's been a huge, long process of discussion and going back and forth. So as I mentioned, the instructor says, well, here's the candidate MOOClets. And then if they're designed with this very simple technology of if-then rules and variables, it's not that hard. One thing that I think is really interesting, and again, getting more towards these kind of Bayesian ideas, is you could think of imagining competitions, right? So this is something that Assessments has been thinking about launching, where they've got this grant to say anyone can propose an experiment. What if we say, here's some math exercises, here's what you can change. Why don't you all propose different conditions? And then we'll run yours if it seems very plausible, but we'll also run it against other people's. What's kind of nice from a Bayesian perspective is, let's take a concrete example of someone asks for help. That ask for help could be, you can almost think of now what we put in there. well, this is sort of a human-computer interaction, human computation idea. It's the idea that, well, human beings are really kind of serve as an element of an algorithm too. So what if I make a call that says, I have a MOOClet, I want to request alternative designs. And then a bunch of researchers will propose these. Well, maybe they say, here's a hint. Maybe they say, here's a message. Maybe they say, here's a prompt. But the idea is that we can now actually sort of have a scalable way of generating designs and testing them. But now we could just put them in equally, right? But again, if you think of setting priors on these different conditions, you can actually have some researchers propose experimental conditions. Some of them, in relevant expertise, say, well, I'm going to give you a rating for how likely I think each of these is to work. The instructor can then give a rating. And you can actually then think about how do we integrate these into being priors on conditions. As you get a very nice effective Bayesian statistics where if the instructors or whoever is right at the beginning, 80% of people go in this condition, 20% go in the other, we find out, and then we change it from 20% to 10 or 0. If they're wrong, with time we'll get data that overwhelms them. And I think what's also nice is that I found this just useful in terms of saying to instructor, if we use the word experiments, I almost feel like we're giving them the wrong idea. We're saying, we're gonna try something crazy that we don't know if it works. I think when people hear experiment, we could actually just sit in. I think they think of shocking people, all kinds of random things. But instead of saying, why don't you give some proportion of people something different? Because we don't know what's gonna work, and we also don't know what's gonna work for whom. Even if you think this is the best explanation you ever wrote, what if one explanation is better for some people than others? Here's a nice piece of technology, you can implement it this way, and then we can smoothly move back and forth. And I think it's really true that we are doing experiments every time we do something. And there's a nice New York Times article. The course, Khan Academy is experimenting on people, but they're putting 100% of people in one condition and 0% in all the other conditions they could run. So they're doing an experiment, there's just no one in the control condition. So I think that's a good summary of everything. And just, I'll flash it for you guys. These are the kind of things I'd be really interested in, seeing people collaborating. Here's a flash of the systems where you can run experiments. Learning strategy modules, adding like a module to a course that has a bunch of strategy tips. This is something where it doesn't really influence the students too much. It's kind of optional for them. Examples. There's just more information about it. All right, well, thanks a lot.
Thanks.
Oh yeah. Sure.
Questions? What of what you talked about is already implemented in any kind of online learning system?
So I think everything I'm talking about is implemented in a test bed course on edX.
Yeah.
So that's a course that I can run and test things out, and I bring random people off Mechanical Turk. The MOOClet part is implemented in the learning tips on edX above, it's like a biochemistry course that's running now. Yeah, and the email part is implemented in most HarvardX courses. We just have to get permission to send emails, that kind of thing.
And you hacked your way into the edX environment, or?
Well, it was very simple. I use Qualtrics, but you could use JavaScript or anything else. So I basically just iframe it in, and then I make it look just like edX. So the idea is that now Qualtrics does all the MOOClet parts.
Sorry.
Oh no, no worries. Yeah. So Qualtrics does the MOOClet parts, and Qualtrics you could honestly just do JavaScript, but basically lets you write down the rules and change the weights. And then that's iframed to edX, so it just looks like part of edX. And you could even set about it with LTI, where, like in Coursera, I could imagine it could pass people grades back to the course environment. We also set up a Google spreadsheet, because Google spreadsheets are likely set up, you can also run scripts in them. So we actually could get people to write hints, like researchers could write hints, and then those could be passed into Qualtrics and shown to people. Or like a machine learning person could say, well, here's your probability, you should send this hint or that hint. Yeah. So that's a bit more real time. Yeah, I'd be happy to share more about that, or even talk by Google Hangouts and show some details of it.
That's interesting, because we had a lot of problems just getting data out of Coursera pages.
Yes.
JavaScript, they banned it.
Oh, they did. Oh, that's a huge pain. Okay.
Yeah, so.
Oh, I didn't realize that. Okay.
I'm wondering whether the LTI plugins are going to be the only way eventually.
Yeah. Do they let you put LTI anywhere in the course?
Yeah.
Oh, well, that's good. Okay. And they ban JavaScript. Do they let you put iframes in? Oh, that's a pain.
Yeah, so that's completely.
Oh, that's a real pain. Okay.
Kind of problem.
Oh.
So that was for us the reason to look at assessments.
Got it. Yeah.
See what it can do for us.
And you could also LTI. You could also get Qualtrics to work through LTI. Yeah, it would be a little bit of work, but I think they actually were trying to make it LTI compatible. I can check to see if they've done it yet. Yeah. Yeah.
And then you could maybe the Coursera environment.
And make it look at exactly.
Because we were thinking we're going to have to build our own.
And
yeah.
What is your stance on the effect sizes that were found?
Ooh.
I'm really thinking, well, are these effect sizes worth the effort? That's sticking in our mind.
Yeah. These specific ones, I have to agree, they're way too small to be interesting. But I do see your point about the heterogeneity of the people. Because MOOC people are not on-campus student people. And the effects are going to be very different. The situation is just so different. Being caught in a program that you didn't choose. Some of these motivational messages might be more effective for people who are extrinsically motivated than they are intrinsically motivated. But I can see other types of manipulations being a lot more effective that are more have to do more with the content.
Yeah, but I'm also thinking about activity really on the content.
Right.
So really give someone a different educational system than the other one to see how that works instead of just some information or hints or.
Well, so when you say with it, what do you? I guess I'm not familiar enough with the problem you're solving. What problems are you thinking about now? What decisions are you making? Like, is it with?
If I'm thinking about effectivity, then I'm thinking about the dependent variable, the thing we're measuring. So if we're in Math Garden, I want to get people better at math.
Yes.
I want to create a higher rating for every specific student. And what I'm thinking is, well, do diagnostics first, see which items are done correct and which aren't. And is there some cluster of items that can be identified? Are they making some kind of specific error, and should we give instruction on that specific error? That logically, in my mind, that would be effective.
I see. Yeah, I definitely see what you're saying.
A lot of information about the system, about the data you're gathering on the specific topic, instead of some general classifications.
I think you're right. I think you're right that has a good chance of being effective. The thing is, when they've done research on those kinds of things, they spend a lot of time building these systems. Like, they actually say that every hour of instruction in an intelligent tutoring system might require 200 hours of PhD time. So I think the one advantage of, I guess, two questions. One is, when you're going to do that, what are your choice points? Is it showing exercise 1, exercise 2, exercise 3? In that case, if you use this kind of MOOClet design pattern, then that just might make your life easier, where you could do your adaptation, but then as a bonus, you could later add in other kinds of content. I think the main thing is these small effects, like, would we expect them to be effective? Like, what's the chance that the first experiments we start running online are like big? And you say, I think the reason online experimentation will be big is not because we know exactly what to do. It's actually because online environments are more like Wikipedia. The first time Wikipedia came out, it was junk. No one would touch it. But now there's no more Encyclopedia Britannica, because Wikipedia is a system where it keeps improving over time. And so the idea behind a MOOClet is that let's take pieces of your system, like your exercises or the hints we give students or the feedback, and let's make them like a mini Wikipedia, because as we get new versions, we can keep improving them over time. And you do the technology so that adding a new version is actually trivial. It's just like, I mean, not trivial, but it doesn't require re-engineering or re-infrastructure. You might have an idea, 2 years later, someone else might have an idea, and then your system then becomes continually improving.
Who were the authors
The authors of these things.
of the hints of the?
So if you have time to do it, then it's you. But I would say that if you set up your system with this kind of way, you can basically get psychologists doing it for free. You'll get psychology people saying, oh, if you can send me some data, then sure, I'll come up with different ideas. You can get artificial intelligence people saying, oh, if you let me try some policies for adaptation, then they will do it for free. I mean, I think actually you could even get them to pay you to do it if you really want to go. Because you can say, well, you don't tell them, we want you to write us hints. You tell them, we're going to run some studies if you pay us X amount to do programming, you know? At least I know lots of researchers who would do that. Like if you want to organize a competition that says researchers propose these things, and I would be happy to help with that. Because you could actually say to them, propose it, but we're not going to run it right away. We're first going to run you with your studies with mechanical Turk people. And if it looks reasonable at all, and then if someone else approves it, well, then we run it. So a competition could be a nice way to.
With respect to the problem you coined, I think finding effects even with this amount of size is indeed very difficult, way more difficult than you would expect because it is in vivo.
Mm-hmm.
But then again, what you say, when you can have targeted populations within the complete population, you can increase your power a lot. So indeed, if you can diagnose a group of persons,
but that point, what you need for that is the information from the systems that you're using. So from the Rekentime, you would need the ratings of the students. You would need all kinds of background information, and only if you have that information, you can really target your information. So that's an essential part to get an API from the vendors and say, okay, these are the variables you can use, because otherwise we're just shooting blanks.
Yeah, I mean, you're the person who does the infrastructure for Math Garden. Okay, you are.
No.
Okay, okay.
It was.
Okay, got it. Because the thing is, I didn't emphasize this as much, but part of the design pattern is that you have modular pieces that pass information. Because the idea is that the same way you can pull if statements and variables, you can actually just add that. So like in Coursera, what it would do is that would be your API. You define your API locally, because if you tell a person build an API, like they're like, yeah, sure, and then 5 years later, eventually they do it. But you say this component sets it up so that it can present different versions based on these variables. If you can pull information from like a URL, a variable store, you can just send it as well. So then as someone clicks submit, you get their time, you get the accuracy, you get a metadata. So that's one way I think, at least it doesn't answer the whole problem, but at least it's a step towards it, you know?
Yeah, I guess if you implement this by design, first step.
But that's the key. Yeah, when you're in Coursera or
yes.
Implementing by design is a bit of an issue.
Yeah, it's true.
Not only a design issue, also a question of who you give access to the data.
Yeah. Yeah, that's true. Yeah, no, it's true.
That may be right.
Yeah. And I think one way you could think about it would be, hopefully as we do this kind of thing, on edX and Coursera too, I think it's not just that they're difficult. Sometimes I wonder, but also they don't have time necessarily to think about all these issues. Oh, sorry, I was